Hello, everyone. This is the section. This section is 5.3. It is about compound interest, and we'll see different formulas. So probably some of you already have seen these, or all of you you've seen them. Um, it's just more preparation to future sections. And these formulas, I think, are enough to do the homework section problems. And in class, I will solve if there are any that are a little bit different, but they all should be around these formulas, right? Um, so compound interest, before we talk about it, there is something, of course, you're familiar with, is simple interest, which just goes with the principal times the rate per year times the time, like per year. So keep that in mind. So if it's like for 6 months, then that should be half, right, for t, because that's half a year. So for t is used per year. So the accumulated amount A, if there is some investment P, and it's given or interest I, or borrowing a P, and it's generating interest I, then what is the accumulated amount? Um, the accumulated amount, of course, is going to be the principal plus the interest for that year. So the future amount, or the accumulated amount, it's also called the future amount. It's going to be P times 1 plus IRT, because we have the principal plus the interest, and the interest is the PRT. So if you factor out P, you get this formula. Um, so if you suppose there is $1,000 deposited in a bank for 3 years, earning interest rate of 8%, this 8% is called the nominal or stated rate, and it compounded annually, for example. Then if we use this formula, this principle, for the first year, we're going to have 1,000 times, that's in the formula 1, plus RT. R is the rate, and the year is the first year, right? And it gives us 1,080. Now, for the second year, if this is compounded, then it's going to start again. So we have A2 equal the principal. But remember, the principal now, after the first year, it became A1, which generate the A1, right? So we started with P. Now the accumulated amount is A1. From this A1, we're going to get a new accumulated amount, A2. And from this A2, we're going to get new accumulated amount, A3. So A2, you can do it this way, or you can just use the previous amount that we had, and that will give you the same thing. Okay. So A1, that's the value that we found. Now times 1 plus RT again. Of course, all this, you don't need to do this, because there is a formula that will, it just this to help you understand what does a compound interest mean. It means that there is an invested amount or a borrowed amount, then there is interest that generates. Then now when we want to calculate the future amount, both are used. Unlike the simple interest doesn't do that. You just have interest PRT, and that's it. So if 2 years, it's multiplied by 2. If it's borrowed 10,000, then 10,000 times the rate, 8% times 2 years times 2. That's for a simple interest. Compounded one, it doesn't work that way. So these steps are just to help you understand how a 1080 is going to be the new amount that will give 1166. Then we're going to do the same thing again. We get 1259. So you probably already know this, and we just keep going. So the first year, the second year, the third year. So, and why this done is in this format, just to show you that when you do this way, you're getting this formula with one. The second year, this is repeated twice, so 2, it repeated 3 times 3, so it comes up as this formula for the accumulated amount. And but there is, of course, an assumption that this is compounded annually, which means each year we just redo the calculation after a year. But that's not the only case for compounded interest. So there is a formula that's going to take care of every case, and I'll leave for you the note here, of course, to see how this transition is going to happen. But this is, of course, the compounded interest formula. This is the formula now that's going to take care of every present amount that is compounded, whether annually, semi-annually, or quarterly. So you have A is the accumulated or future amount, and P is the principal. R is the nominal interest rate per year. So remember, it's per year. M is the number of conversions period per year, which means how many times this thing got compounded. And T is the term. So are we looking into mortgage of 10 years, 15 years, 30 years? So that's what T stands for. So let's look at some example. Find the accumulated amount after 3 years if $1,000 is invested at 8%. So let's first, annually means N. Usually if you look online, you're going to find the compounded formula and they use N. And here we use M, it doesn't matter. So, but we know it's one time per year. One time per year. The period is 3 years. This is 8%. So you switch it. This is $1,000. And if we use, remember that formula, that if you use it, you can do this way, or you can just set up this formula, and M is 1, right? So A, 1,000, 1 plus 0.08 over 1, M is 1 times 3. So something like this, right? So 1,000, 1 plus, you see, and this 0.08 over 1 is 0.08. Power 3 is that, right? So this is previous one, or let's just say formula 6. And you get $12.59 and $71. So let's look at if it's semi-annually, right, which means twice a year. Then M is 2, and you see M there is 2. And you just redo the calculations again, and you get 1256.32. And so D, quarterly, so it's 4 times. Monthly is going to be 12. And daily, whichever is given, usually it's 365. Right, so same calculations again. Quarterly, M is 4, so 4, 4, same formula, 1268.24. So please try this, practice it with your calculator so you make sure you get correct answers. Don't assume that you may get correct answers, because it depends on what calculator you're using. The steps may be different. You may do the parentheses inside first, like 0.08 divided by 12. Then you add a 1. equal, then you do exponent 36 times 1,000. So you may work it that way to get 1270.24. And same here for daily, 365. That's going to be more expensive. And you can see here what's going to happen is we have the 8% each time, right? And depends on how this thing is compounded. And we have the same period, 3 years. And we have the same investment, 1,000. And you see what it generates. Not the same, right? So here, what we're going to look next is this table is going to be the same thing, just for the transition as we look into effective rate. So if we don't want to do this calculation each time this is compounded, what is the rate? If we want to use that simple formula or that formula for annually, right, which is the same that we saw, what would be the rate? It won't be 8% each time, because you see, if we use in the same formula, let's show you this formula here that was generated by the assumption that this is compounded annually. If you're using this is 8% and this is 3, you're going to get the same A all the time, which is not going to be correct. So if this is not compounded annually, it's compounded different times, but you still want to use the same formula, what is the R? What is the true R? And that's going to be the effective thing. So that's what's happening next. Effective rate of interest. This effective rate of interest is simple interest rate that would produce the same accumulated amount in 1 year as the nominal rate compounded m times a year. The effective rate is also called the true rate. This is the formula for it. It's connection with the nominal rate. You're given, let's say, 8% as the nominal rate, and you want to find the true rate or the effective rate, depending how many times this thing is compounded. So let's do some example. We'll keep the same example so I understand what's going on. So let's look at previous example, and 8% compounded once, and we use this formula 7. So we just set up these numbers and we get the same thing. So for 1 year, that's the check. For 1 year, this is same as the nominal rate, exactly the same. Now, if it's compounded, of course, here for m equal 1. Now, if it's compounded semi-annually or twice per year, and you use the formula 7, you get 8.16%. So that's the true rate. Same thing now, if it's quarterly, you get 8.24%. If it's monthly, you get 8.3%. And if it's daily, you get 8.33%. This makes sense because, as you remember, in this table, you see these increase. And if you use 8%, you get this. So what number you should use in the formula so you keep getting these numbers if we're not using the other formula of the compound interest? So these are the numbers we need to use, these true rate or effective rate. That's it. So the future amount or the accumulated amount is that principal, $1,000, 1 plus whatever true rate for the period we need, and with T. That's it's the same. So this is the same as the other formula we did that we looked at. Look at the table that maybe table 2. This is the same thing. So the difference here is we're not using the compound interest formula. We're just using like a simple interest formula, but instead, you see these 3 here is the same, right? But here, these are the effective rates or the true rates, not the 8%, right? So, so it is annually, it's the same, 8%. If it's semi-annually, it's 8.16%. If it's the other and the other numbers, right? The 8.3% and 8.328%, and we're getting the same exact numbers. So here you have 2 ways of figuring out this thing. And that's the purpose of this, is to understand the different ways. So you can use the compound interest formula with the M, right? And the T to find that. Or you can use, or you can find the effective rate, and you just use the regular interest formula, which is this one, just like the simple interest one, and you get the same numbers. Yeah, so the homework questions will be similar. Find cumulated, there is this, find the effective rate, find similar requests. The other request is find the present value. If you're looking into some investment, you're looking into some accumulated investment or payoff at the end, and you want to know how much it should be invested now as a present value, and you figure out that. So it's not new, but it's this formula again. It just now, this is the accumulated and this is the present. So think about solving this. If you divide by that, both sides, you get this. Right? And remember, this is an exponent. We know exponents, we can bring it up by making it negative. If it's negative, it comes down. So the P is A times 1 plus R over M minus MT. So this is the same formula now, is used if you want to find the present value. If you know the future value, or you want to have a good prediction to the future value and based on a certain present value, then you use this formula. So for example, how much money should be deposited in a bank paying interest rate of 6% per year compounded monthly, so 12. So at the end of the year of 3 years, the accumulated amount will be 20,000. So A is 20,000, R is 6%, monthly is 12, and you do this and you find it's 16,713. There is another form of interest. It's called compounded, continuous compounding. It's different than the one we just saw. This one just keeps compounding, and it has its own formula using the exponential E with the RT, and P still stands for the principal and or the present, and A stands for the accumulated or future value, and R is the annual interest rate, and T is the time in years. So for example, $1,000 in 3 years, 8%, And we're going to compare if it's compounded daily, 365. So now you see this is compounded, not continuous compounded, daily. And that's going to be a 1271. And let's see if it's continuous compounding, 1271.25. Yeah, so this is, so you see the similar, this continuous compounding is similar to compounded daily. If we solve same thing, if we take this formula and we divide by ERT, we get this. So, and we know that's a negative exponent if he needs to come here. So similarly, we can find the present value by, if we know the future value, by switching these, and you can have some other examples on it, right? And this is some other examples, and this is for a real estate, and you have the market value as 300,000 with E square root of T divided by 2, where VT is measured in dollars and T is the time in years from the present, and it is expected rate of appreciation is 9% compounded continuously for 10 years, and find an expression for the present value of the market price of the property valid for 10 years, compute P7, P8, and this and that. All right, so if we look at this formula 11, continuous compounding, to find the present value, we can just use these here. So the market value with the E and the 9%, and we can substitute the V. Here is 300,000. Let's write it 300,000. And if you multiply it, which is this one, then you multiply it by this. So you see the same base, which means you're going to add these exponents. And that's what you have here. Now you can try for 7. And you can try for 8, and you can try for 9, and find these p values. All right, cool. So this is not bad, just understanding how these formulas and how to do the calculations correctly and distinguish between different type of interests.